All right, y'all, I just wanted to give y'all a couple extra examples for these types of problems, finding area between two curves. So we're going to do these practice problems. I'm going to go quickly, but feel free to, pause, rewind, uh, anything like that if you need to. Okay, cool. So this is one of your Khan Academy practice problems, and it's a good practice problem to have, very aligned to the AP exam. So we have let f equal this function, and then let, this whole function, and then let g equal this whole function. Find the sum of the areas enclosed by the graphs of f and g between, these are important, x equals -2 and x equals 3. So they gave us our boundaries, -2 to 3, and then luckily, yay, we get a graphing calculator on this one. And remember to always round your answer to 3 decimal places. Actually, we're not even, okay, in Khan Academy it makes you round, but on the AP exam we're not even going to round. But today we're going to have to round because of Khan Academy. Okay, so the first thing we need to do, y'all, on the graphing calculator is go to y equals and graph both of these things. So graph f and graph g. So I already prepared that. If you go to y equals, you can see that I typed in my f function, I typed in my g function right under it. And then here's what I want you to do. If you press graph, your window might not look like this. Like it might not show you the exact same graph. So what I want you to do is press zoom and then 6, zoom 6. That's going to basically set you up to have a window from -10 to 10 on your x and y axis. Cool, so it just gets you to the normal zoom. All right, and let's go back to the problem really quick. We're trying to find the areas, the sum of the areas enclosed by the graphs of f and g between -2 and 3 on our x-axis. So let's look at these graphs. We see -2 right here, which I don't think I can actually like show you. We can see x equals -2, but we can't see where they intersect at x equals -3. So what we're going to do is press window, and we're actually going to adjust our window. So let's press window. And we want to see, if you look at the graph, you can always go back to graph. We want to see higher, right? We want to see higher on the y-axis so that we can see that intersection point. So go window, and I'm going to go to my y-axis, my y max. I want to see higher. Maybe 12. Try that. Press graph. Oh, we still can't see that intersection. All right, so I'm going to adjust my window to something that I know will work. So I'm actually going to adjust my x's as well. I don't need to see the -10 on the x-axis. I don't need to see the +10 on the x-axis, and I don't need to see the -10 on the y-axis. So I'm going to adjust my window just so we get a better picture of this. I'm going to make my x-axis -3. I'm going to make my x max like 5. My y min, I'm going to make also -3, and then let's try 15 for the max and see if we will be able to see that intersection point now. Oh, barely. So y'all, this is just to show you that you may need to adjust your window. Let's go to where y equals 20. And I wanted y'all to have practice adjusting the window. Okay, cool. So now we can see where our graphs intersect, and I'm going to snip this actually. We're going to put it in our OneNote. But you would be able to see this on your calculator and look back and forth between your calculator and your like paper. Okay, cool. So this is really big. We don't need it that big. So now we can see this on our calculator. We know that we're trying to find the area bounded between these two curves from x equals -2. So -2 is right here, and then x equals 3. 3 is 1, 2, 3 right here, and we can see that that is where they intersect. Okay, cool. So we're trying to find this area. I'm actually gonna, yeah. It's hard to highlight it when the sliver's so small. We're trying to find these areas. All right, so let's do it. Luckily, this is Calc OK, so all I'm going to do is actually write the integral, and then I'll plug that integral into my calculator. So the area equals A equals, do we know which function is top and which one's bottom? Well, this one's a quadratic, so it should be a parabola shape. So that looks like my red function here, right? On this graph, that's my red function. So I'm going to label that, actually, this is g of x, is that parabola function, and then this one is f of x is a polynomial cubic. So it's going to be like a cubic, has the shape of like squiggly, and that's the blue one. So I'm going to actually change that to pink. If you didn't know that, you could always like use your calculator to check, like on the graphing tool. Okay, cool. So A equals, and remember these switch. This is top here, pink is top here, orange is bottom here. Pink is bottom on this side and orange is top. So we're gonna have to do two integrals because they switch top and bottom. So the area equals the integral from -2 to 0 is where the top is pink. So I'm going to go -2 to 0 of my pink function top minus my orange function bottom. So of f of x minus g of x. So 1/2 x cubed plus 1/2 x squared minus x minus my g of x function x squared plus 2x. Okay, that's just this left sliver, this left area right here. Now we need to do the right area, so let's add plus the integral from 0 to 3, right? 0 to 3 of my orange function is now my top function, so x squared plus 2x minus my pink function is my bottom function. So we have 1/2 x cubed plus 1/2 x squared. I'm going to run out of room. Minus x dx. Okay, so there's my integral. I'm going to show you a really, really sweet trick to do this integral in your calculator without having to write all of this stuff out on my calculator every time. Are you ready? Super cool trick. Make sure you pay attention. All right, so in your calculator where you went to y equals, you actually gave these functions names. So this is y1, so you can see the top one is called y1, the blue function, and the orange one is called y2, right? So we can actually use those names in our integral. So let's just make sure we know which one's which. y1 is my cubic function, and y2 is my quadratic function. So let's go back to OneNote. This is y1. y1 is my pink function, my cubic, y1, and then this is y2 in my calculator. So another way we could think of this integral, and you don't have to write this, but this is like what we're about to do in our calculator. We're about to do y1 minus y2 here, and then plus the integral from 0 to 3 of y2 minus y1. You can actually type this, oops, and I forgot my dx, so let me just, you can actually type this in your calculator instead of having to type all of that other stuff out. So let me show you how to do that. This is going to be a huge time saver on the AP exam. So here we go. We're going to do -2 to 0 of y1 minus y2. So I'll do that one first. So get out of here. Second quit. We need to do our integral. So math 9. We're going from -2 to 0. And then remember, we're going to do y1 minus y2. So how do we get y1 and y2 here? Let me show you. You're going to go to second, oh, hold on. Now I'm starting to, it's going to be alpha trace. Alpha is the green button, and then trace. Instead of second trace, alpha trace. And you can see there's y1 sitting right there. So you can like move on these and choose whichever y you want. Those are the ones that you set up in y equals when you press y equals. We wanted y1 minus y2. So we're going to press y1, subtract, so minus, and then alpha trace. Let's grab y2. And then dx. Plus, so what we did here was we set up this integral, right? Now we need plus the integral of y2 minus y1 from 0 to 3. So let's do that one. So plus math 9, the integral from 0 to 3 of, it's flipped. We're going to do y2 minus y1. Sorry, y'all, it's not letting me. There we go. Alpha trace y2 minus, and then alpha trace y1. Okay, you can also type in all of the function stuff, but I don't know. I like this. You don't have to type, you won't make as many mistakes if you can do it this way, because you don't have to worry about parentheses. You don't have to worry about typing it all out. And it's going to not be like this long thing in your calculator. It's pretty simple. It's pretty easy to make sure and check, did we do it right? And yes, it looks like we did it right. So let's press enter. And you get 10.541, which let me just make sure that's the correct answer. Yes, it is. Okay, so 10.541, and it told you to round, so this is something that I want to make a note of. A equals, in the AP exam, 10.541. We're going to just cut it off after 3 decimals. But Khan Academy asks you to round, so you have to look at the next one. So this is the AP exam answer. That's that area, that blue area. But for Khan Academy, we have to actually look at the next number, which is a 6. 10.542, because you have to round the 1 up, because the number next to it to the right is a 6. Okay, sweet. So that's that problem. This is what you need to put in Khan Academy. And let's do one more. One more practice, one of your Khan Academy problems. All right, this one, we're not going to use a calculator, and you need to be able to do these problems without a calculator, because sometimes the AP exam will not allow a calculator on these problems. So let's do this one. The curve x equals 144y over y squared plus 4 squared is graphed. Okay, so we have this graph down here. Cool. What is the area bounded by the curve, the y-axis? Okay, I'm about to, whenever it like says area bounded by and it starts listing off things, I like to make sure I mark those things on my graph. So let's go ahead and do that. What's the area bounded by the curve? So the curve is this blue function. So that's already marked. Oh, wow. And it's the exact same color blue that I use. So let me change that to a dark blue. Here's the curve. And this is like a good skill to have, to like mark off your boundaries. So bounded by the curve. The y-axis is my next boundary, the y-axis. So I'm going to mark that in orange. Here's the y-axis. The line y equals 0. So the line y equals 0 is actually your x-axis. This is where y equals 0. And then the line y equals 6. That's this line. Well, if we were going to draw the whole line, that would be this line, right? And that's how they got that blue shaded region. Sometimes they won't shade this for you. Sometimes they won't shade this for you. They'll just like tell you all those things like, oh, it's bounded by this, 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 and this. And you're going to have to figure out which area to shade. But now we know, okay, this is the area we're trying to shade or find the area of. Cool, let's move on. And it's actually good to know that we're going from 0 to 6. So I'm going to write that 0 to 6. Sweet. So how do we find this area? Well, this, you may notice, is a function defined, it's a function of y, and it's defined as x equals something. So this is where we're going to be integrating up. We're going to be going from down here from 0 and adding up the area this way, 0 to 6, adding up the area vertically. Okay, you may recall that when we're set up this way, your area is going to equal the integral from c to d of right minus left. Instead of top minus bottom, we're doing right minus left with respect to y. Okay, so let's go ahead and start trying to set up this integral. A equals the integral from C to D, that would be from 0 to 6 because we're integrating up and down now. My right function is this curve. This is my right function. And then my left function, which is kind of weird, is this line, this orange line right here that you can see. That's my left function. And what is that in terms of x? X equals what? Because remember, our functions need to be in terms of what x equals. So what does x equal there? X equals 0, right? On the y-axis, your x equals 0. That's the equation for that orange line. So we're going to do right minus left. So we're going to write our right function, 144y over quantity y squared plus 4 squared minus our left function, 0, with respect to y. Luckily, this turns into a nice, easy integral where we don't have to simplify. Well, it's not easy necessarily, but we don't have to worry about the second function because it's 0, right? So it disappears. So here is all we're trying to do is integrate this. Cool. And again, we are not going to use our calculator because we really do need to know how to do this by hand. So how do we do this by hand? How would we take this integral? This is a tricky integral. It's got some u sub going on, right? We've got some u sub. So what would u equal here? I'm going to do it. Hopefully you recognize that u is y squared plus 4. Du with respect to y is 2y. So that means that dy equals 1 over 2y du. Cool. So now we can like rewrite our integral. The integral from, remember, we're gonna come back to these boundaries. I'm gonna leave those blank for now. We'll plug them back in at the very end. So 0 to 6 isn't gonna be the boundaries for now. So let's go ahead and plug in our like u and stuff. So we have 144y over, and then u squared. And then times 1 over 2y du. Cool, you can see that these y's cancel. So equals the integral, we're not doing our boundaries until the very end, of 144 divided by 2 is 72. 72 over u squared du. Okay, sweet. And now we're ready. Oh, we're not quite ready to integrate. Let's rewrite it. And I'm actually going to we're just going to go to the right over here because we're about to do a bunch of integration. I'll leave like this up. There we go. Equals the integral. I want to rewrite this to 72 u to the negative 2 du. Cool. Now I'm ready to integrate it. So that equals, I'm going to integrate in, let's see, what color should I integrate in? Green? Equals, all right, we have 72 u to the negative 1 over negative 1. And then we need to rearrange this. Don't forget, we're going to have, I keep forgetting to add these boundaries. We do have boundaries. So like we're going to have boundaries, but we're not plugging those or like putting them back in until we change back to y's. So equals, we got to change back to our original variable. This will be negative 72 over u from whatever boundary to whatever boundary. Okay, and now we're going to plug back in for u, and then we'll put our boundaries back in. So what was u? U was y squared plus 4. So equals, I'm going to come over here, negative 72 over y squared plus 4 evaluated from, now we can put our boundaries back in, 0 to 6. Because we changed our variable back to y, the original variable. Okay, and we are so close to being done. Now we just need to actually plug in top, subtract, plug in bottom. So let's do it. We have equals negative 72 over 6 squared plus 4 minus negative 72 over 0 squared plus 4. And that will equal, here, I'll do it here, negative 72 over 36 over 40 minus negative 72 over 4. And these double negatives minus negative 72, that's going to turn into positive. So we have negative 72 over 40 plus, and then let me get a common denominator of 40. It would be 720 because we multiplied by 10, right? Sorry, plus 720 over 40 equals, all right, this would equal 648 over 40. Cool. And then I think we'll probably need to simplify. So let's see what happens when we simplify. You can divide both 648 and 40 by 8. So it'd be 80, I think it's 81 over 8. And let me just like confirm before you put these in to your Khan Academy. We're just simplifying that fraction. 81 over 8, is that correct? Yes. Oh, wait. Oh, sorry. 8 goes into, silly me. 8 goes into 648 81 times. 8 goes into 45 times. So we just, 8 goes into both of those evenly. 81 over 5. That's your answer. Okay, so we know how to do these by hand. That one was kind of tricky because it involved U sub. But yeah, if you need any additional support, please reach out. But hopefully these practice problems have helped you just get more confident and a better understanding. And good luck, y'all. Bye.